Hello, everyone. I'm Ramzi Alqrainy. I'm from Jordan, and I'm really excited to talk to you about the Arabic content with Apache Solr. So firstly, I want to ask you, who dealt with Arabic content? Wow. So, firstly, I will explain myself. Who is Ramzi Alqrainy? Ramzi Alqrainy is one of the well-recognized experts in artificial intelligence and information retrieval in the Middle East. He holds a master in computer science with the first rank in data mining and information retrieval. He's currently managing the search and reporting functions at OpenSeoul with position Senior Enterprise Search and Data Engineer. I know it's complicated, but we are trying to summarize it. So he's technical reviewer for Toolbox and co-founder for Solr Arabic Group, built 8 search engines in the last 2 years with different models, and he's an active blogger and a presenter about information retrieval. In this presentation, we'll cover 2 topics: the importance and the challenges of Arabic content, and how we can use Apache Solr to solve some of these challenges at OpenSeoul as a real case study. So today, we'll talk about why is Arabic language important, Arabic language is complex, how we use Apache Solr at OpenSeoul, localization concept with Solr Cloud, ranking and relevancy, and finally, Apache Solr implementations at OpenSeoul. So before starting with the importance of the Arabic language, let's talk about the origin and the age of Arabic language. Well, the earliest surviving text in Proto-Arabic or ancient North Arabia has seen inscriptions of Eastern Saudi Arabia from 8th century BC. From about 2nd century BC, a few inscriptions from Qaryat al-Faw reveal a dialect which is no longer considered Proto-Arabic, but pre-classical Arabic. Pre-Islamic Arabic and Arabic alphabet, these are very few, with only 5 known for certain. These mostly do not use dots, making them sometimes difficult to interpret, as many letters are the same shape as other letters. In the 7th century, and probably in early years of Islam, while writing down the Quran, scribes realized that working out which of ambiguous letter, a particular letters from context was laborious and not always possible. So a proper remedy was required. By analogy with this, a system of dots was added to the Arabic alphabet to make enough different letters for classical Arabic's 28 phonemes. So today, the Arabic language is ranked as the 4th top language on the web. It's the fastest growing it's the fastest growing language among all the languages on the web. So the number of Arab internet users grow from 65 million in 2011 to 135 in 2013. So we talk about double. Let's talk about the complexity and the challenges. So Arabic language is complex. Arabic poses many challenges for retrieval. When dealing with the social media such as microblogs and informal web content such as discussions and forums, introduces further complications. These complications relate to the use of text decorations, abbreviations, and other challenges. So the first challenge is Arabic orthography and print. So Arabic has a right to left connected script that uses 28 basic letters. So for example, the letter Ain, this is one of the letters in Arabic, has many forms based on its location in the word. So beginning, middle, end, and separate are completely different. So this is one of the complexity in the Arabic language. Another complexity, which is Arabic diacritics. So Arabic diacritics help disambiguate the meaning of the word. So for example, alama, the word alama, alam meaning flag, but ilm means knowledge. So the same letters with different diacritics goes to different meaning. Of course, most of Arabic content in the web now is without diacritics. So the common approach to handle this challenge is to remove diacritics. But this has a trade-off that will make an ambiguity in the search engine. Okay, the complexity of handling the Arabic language comes from the morphological variation. So you can generate several words from the common root. So Arabic words are divided into three main types: nouns, verbs, and practice like preposition. And the word in Arabic has many affixes and many affixes. So further, plurals can be constructed by adding many of affixes, so producing so-called broken plurals. So Arabic nouns, which include adjectives and adverbs, and verbs are derived from the closed set of around 10,000 roots. So for example, the root kataba. Kataba means write. We can produce kitab, book, katib, writer, maktub, written, and kutayib, small book. With the spread of online social interaction in Arab world, Arabic dialects started finding their way to online social interaction. So there are 6 dominant with many variations of them and dozens more or less spoken dialects. Of course, there are several factors that make dialects different. Different dialects may make different lexical choices to express the concept. So the concept corresponding to I want, in Egyptian, we can say it عاوز. In Gulf, أبغى. In Iraqi, أبي. But in Levantine, بدي. Levantine includes Jordan, Syria, Lebanon, and Palestine. The last challenge, which is the transliteration form, Arabizi. So Arabic is sometimes written using Latin character and translator form. It's so popular. And Arabizi uses a numeral to represent Arabic letters. For example, when we say Ahmad, Ahmad, A-H-M-A-D. When we will write to, in translation form, A represents 2, and H represents 7. So 2, 7, M-A-D. This is the translation form of Ahmad. Let's go to next part, which is how we can use Apache Solr to solve some of these challenges at OpenSeoul as a real case study. So firstly, what is OpenSeoul? OpenSeoul basically is a leading classified ads websites in the Middle East and North Africa. It's similar to Craigslist. And this website, which is available in Arabic, serves more than 250 million page views per month. Right now, we have more than 7,000 concurrent users with more activity per second by adding posts and adding comments and other interaction. And we have more than 40,000 hits on Solr per minute. So the question, how we can build Arabic search engine? Of course, there are several challenges that needed to be addressed and for Arabic search, namely efficiency, language handling, and ranking. So efficiency, due to the large scale of the web, all processing must be very efficient. So we'll talk about Solr Cloud. Let's talk about the language handling. And what are the main processing that we should apply for Arabic language? So firstly, we'll talk about tokenization. The tokenization phase, as we know, that we need to break down that sentence into tokens. After that, we need to remove stop words to increase the performance and to improve the recall. After that, we need to apply Arabic normalization algorithm. And Arabic light stemming, not full, but light stemming. And finally, adding synonyms for high accuracy. So let's talk about Arabic normalization. Humans frequently make mistake in normal writing. So there are common spelling mistakes that are widely accepted. For example, adros. Adros means study. So we should add the first letter, alif, in the first letter. So Arabic content would be normalized according to the following steps. Firstly, remove punctuation. Remove diacritics. Remove diacritics because the most Arabic content in the web is without diacritics. So the common approach is remove the diacritics. After that, remove non-letters. Replace these letters from the first letter in each word. Here we can say it's uniform and unified the process. So replace the first three letters in each word, and we can say it alif, A, and replace ya, which is in the final letter, in the last letter, and finally replace ta, ha. Okay. Here we can uniform all the words to build a successful search engine. Let's talk about Arabic light stemmer. So stemming is one of the many tools beside normalization that is used in information retrieval to combat this vocabulary mismatch problem. So a light stemmer is not dictionary driven. Here we talk about why we don't have a full stemming. We have many reasons for that because firstly, the Arabic language is very difficult. Secondly, because we have broken rules. Third, because we have user-generated content, and the users always do not write most standard Arabic. So here we have more than an algorithm for light stemming. We have light 1, light 2, 3, 4, 3, 8, and 10. So we talk about the prefix removal mechanism. If we compared these algorithms together, here we see, firstly, raw means no normalization and no stemming. Norm means we have normalization, but without stemming. And other techniques. So here, light 10 outperformed the other approaches. It's becoming widely used in Arabic information retrieval. So that's why it's very popular, and we can use it properly. What about exceptions? So of course, because we talk about Arabic, we have an exceptions. So here, sometimes stemmer may not do what you want out of the box. So here we use one of the benefits of Solr, which is put an exceptional words in protected words, the text, and use it in search flow. And we will explain it in the other slide. Finally, we'll talk about removing stop words and adding synonyms. So removing stop words is important to ensure high performance and to increase the recall. This link includes most of stop words in the Arabic. So matching strings of tokens and replacing them with other strings, we can improve recall and the precision. How we can build this in Solr? Of course, we need to build a TextField. So here we build a text_AR. Firstly, we talk about standard tokenization filter, and we make all tokens a lowercase for non-letters Arabic. After that, we remove stop words and all the stop words and stop words _AR. After that, we'll apply Arabic normalization and Arabic stemming, which is Arabic light 10. And the exceptionals, we use keyword marker filter factory for exceptionals and stemming. And finally, adding synonyms in synonyms the text to improve the recall and the precision. As we said before, that Arabic dialects started finding their way to online social interaction. So the question, how we can build a localization concept with more efficiency, with Solr Cloud especially, by using the collection concept. So here we have 4 charts, 2 leaders and 2 replicas, and every chart contains 5 collections for every area. So we have Egyptian collection, Gulf collection, Levantine collection, Iraq collection, and Tunis and Morocco collection. Every collection has independent synonyms, independent configurations, and independent index. So from application level, you can predefine what collection you need. And we used a zookeeper ensemble, a distributed zookeeper, for high availability, for fault tolerance, and centralize the configuration in Solr Cloud. Let's talk about ranking and relevancy. The most important factor in classified ads is freshness and the document age. So just do descending sort by age? The answer is not, because we don't need to sort. We need to build ranking formula. So the freshness is one of the factors, but we need to build a ranking formula. So here we need recency boosting. So the most question, how we can retrieve a recent, relevant ad. By adding recency boosting in the formula, boost more recent documents and penalize older documents just for being old. So here, we use this document to give high boost for the more freshness by using boost function, how we can use it in Solr, by using boost function and recep function. Boost function attribute, and recep means reciprocal function. Here we can adjust the value, and we have many variations about that. Many variations about using reciprocal function. So the best in our business model, which is OpenSeoul, is the green light. So here we increase the boost when the document is more freshness and decrease exponentially the boost when the document being old. By the way, here 3.16 exponential of 10, this means about approximately the year has 3.16 exponential of 10 millisecond in a year. So one can scale days to fractions of year with the inverse. So that's why we have -11. And here, what's the other Solr implementations at OpenSeoul? We have other implementations like anti-spam, using Apache Solr, checking relevancy, how to know that this post is relevant to this, to its category, tags generation, how to generate tags from the post and the content, and finally, recommendation system by using similarity functions at using OpenSeoul. And thank you for your attention. So let's talk about questions. Any questions?
So you had to have separate synonyms, you had to have separate collections?
Of course, of course.
Okay.
Of every area, you have different synonyms with different collections, because, for example, in Egypt, hotel means okanda, but in Jordan, funduk. One of the other examples In Libya, Mercedes means Marshides, but it's wrong in Jordan. So we cannot combine these synonyms in one collection.
Do you see any special challenges even within regions, say within Egypt or within Jordan? You know, basically north, south, central, different areas, because usually, you know, within a country, just like here, God knows nobody can understand me when I speak New Yorkese. You know, there's that element of an accent.
Yeah,
And there's also context
of course.
between, you know, between words. Game, the, you know, how do you see development of contextual engines within, or, you know, I'm just curious because this is a whole new thing to me.
Of course. Here we introduce some of challenges in Arabic language. The answer is there are an intersection between all these dialects, and the Arabic language is about one language in all countries. So there are intersection. The challenges is the localization concept, not more than grammar. So the grammar is the same in all countries, and the basic is the same, and most standard Arabic is the same in all countries. So the big challenges here is Arabizi, for example, and the localization concept. That's why we need to build a different and independent collections for every area. Mm-hmm.
Thank you very much. I appreciate it.
You're welcome.
Are there freely available tools to take Arabic script documents and convert them to Arabic?
Yeah, of course. In Arabic, we can use Yamli, this an open source API. You can provide an English or Arabizi form and convert it to Arabic form.
What about the other way?
And otherwise, yeah.
That's an API that you use on the internet, or just you download?
No, over internet. But it's easy to build an API because it's about a mapping. So you map 2 represent to A or Alif, and 7 represent to Ha. Okay, so it's easy to build a mapping and an API for Arabizi, by the way. Mm-hmm.
You said you disregarding diacritics. That's critical.
Okay, diacritics is one of the challenges for now, and this is we talk here about the traditional search engine, not semantic search engine. So the difference, we need to build a semantic search engine to understand the word based on the context, and this we cannot do it in the first phase. Firstly, of course, removing diacritics will increase the ambiguity, and this is one of the disadvantage of Arabic normalization, by the way, and this stage especially. Yeah.
So I've read about projects that can add diacritics back to French. Are there similar projects for Arabic that attempt to?
Diacritics of French.
That attempt to put diacritics back in to
Yeah.
text, which has that.
The problem is most of our content in the web is without diacritics. But if you have a diacritics content with diacritics, of course it's easy to build a semantic search engine, because diacritics help the search engine to know the type of the word. For example, if the last diacritic of the word is sukun, means this is noun. But if the last diacritic is fatha, means this is verb. So will help you to build a semantic search engine. But we said before, that the big challenge here is the most Arabic content is without diacritics. That's why Google built a forums to build an accurate index for more localization in the web.
My friends here who know me will be shocked, but in graduate school, I actually wrote some code for computer-assisted instruction language that involved, for example, one of the steps down the line was noun replacement.
Yeah.
And we would, or vowel replacement, and we would sort of take multiple passes to figure out the relevance. Does it match with this? Then word client transformation,
Mhm.
and we actually had vowel replacement, and we also did, we had a replacement alphabet.
Yeah.
A, B, C, D, A, B, C kind of thing.
Yeah.
But we do multiple tiers of relevance to try to guess. Do you do that, or is it one shot, do everything? And then
By the way, most of Arabic word retain to the root فعل. So 54% of the Arabic word retain to the فعل root. So I cannot build a dictionary driven or a dictionary driven to every time I use it to give me a better solution. So that's why we need to build an exceptional rules, because we have an Arabic words like internet. Internet means in Arabic internet. So how we can deal with this word? So this is another problems. Other problem, you can generate several words from common root. So how we can build a dictionary driven to deal with this? This is one of the other challenges. By the way, we are working on that in Jordan for building estimator with high accuracy and relevancy and returning to root systems with high accuracy and recall. Charlene.
So when you're querying all these collections, do you do any language detection, or do you already know that the user who sent this query is in
Yeah.
this geographic location, so that you can always route it to the correct collection?
Based on business model, you choose the site. So the site is, for example, this site for Egypt and this site for Jordan. So this is the predefined collection, and there's no need for language detection.
Have you ever tried to search, sort of federated search across different regions? And if so, what have you done to overcome challenges of different language?
Sorry, I did not get your point.
So right now, you completely separate
Yeah.
by region
Yeah.
your processing, so you don't have to worry about a speaker from one region.
Of course.
Search for documents in another.
Of course.
So my question is, have you ever tried to build
One collection?
that need to have queries in one language match documents in another language?
Of course. When build, for example, one of the systems I have built, Quran. The Quran and the Hadith dictionary. This is common for all Arabic content and Arabic language. Here we can use one collection, for example, for all Arabic people to use that. But here my concept, how to support localization. That's why I strongly need to build an independent collection to solve this problem. Yeah, the Quran is Mus'haf, yeah. And the Quran is with most standard language for all Arabic people. So there is no need to build a localization because we have one Quran.
But actually, just following up to that, so is dialect detection fairly easy? We try to classify
Arabic dialects or diacritics?
given some text,
Okay.
predict which dialect it is.
Of course, it's not easy. Of course, it's not easy.
And that brings up an interesting situation. It's like, well, if I take the job, I speak New York, which has its own dialect.
Yeah.
So as you can tell, so right now I'm in Virginia. So if I'm speaking New York
Yeah.
and I have my own context and then this becomes a challenge.
Yeah, of course, of course. This, how we can solve this problem? By using synonyms. So, using synonyms. For example,
Oh, yeah, if you have
yeah,
that, you could do that.
I have built a neural network system that if you always search for Okanda, for example, Okanda means hotel, and click on Fondok, so that's mean Okanda and Fondok are the same. So I will put it in synonyms.
Okay, so you have almost like a list of synonyms that.
Of course, for every country.
Well, vertical slice.
So yeah.
Sweet, thank you.
But I think yeah.
Yeah,
Mhm. We can take it offline. We can take it offline. Thank you. Thank you.